Hi all, in this video let's see about the data transformation. So what are the different things that you could see to transform the data, the different methods you could do to transform the data. So let's see, the first one is smoothing. So this is mainly used to remove the noise from the data. So we also in the last video we saw about binning, that is mainly used to remove the noise from data by categorizing the similar data and putting them into the bins. Okay, so smoothing is one of the method that is mainly used to remove the noise from data, and the techniques are binning, regression and clustering. So what is aggregation? Aggregation is also a method. From the word aggregation itself, you can understand aggregating something, where summary or aggregation operation, you aggregate, you put them together, you summarize something. So this aggregation operation is done on some data, whatever the data set. So the aggregation is applied on the data set to transform the data. Suppose if you have 4 files, suppose you have each file for a week, so you can aggregate all 4 files. So for a month you have 4 files, for a week you have 1 file, this for a month you have 4 files. All those 4 files can be aggregated into a single file, so that you can have only a single file for a month. So all the 4 files can be aggregated into a single file. That is what is meant by aggregation. The daily sales may be aggregated so as to compute monthly and annual total amounts. So the next one is your generalization. So generalization is nothing but where the low level or primitive raw data are replaced by the higher level concepts through the use of concept like hierarchies. For example, you might know, like, you have a street name. So this street name could be a lower level. So this street name can be generalized or replaced with the higher level concepts like city or country. So few attributes which are in the lower level can be replaced with the higher level concepts such as city or street. For example, there is a street that can be replaced with a higher level hierarchy such as city or street. So this is what is aggregations. So for example, you can have a numerical attribute like age, where this age can be mapped with 3 higher level concepts like youth, middle age and senior. So these are the 3 methods that we have seen now for the data transformation. Okay, so the another method we are going to see is normalization. So in this normalization we have 3 methods, and smaller problems also we are going to see in the normalization. So what is normalization? Where the attribute, each and every attribute might be in different ranges. So these attributes data are scaled so that it can fall within a specified range. For example, within the range from -1 to 1 or from 0 to 1. So normalization main aim is to make sure the data is scaled up to a specific range. This is what is normalization. Attribute constructions or future constructions, where new attributes are constructed and added from a given set of attributes to help the mining process. So this is also one of the concepts, we call it as attribute constructions. What is this attribute construction? This is also called as a future constructions, where this attribute construction means that new attributes will be constructed and those attributes will be added up to the this new attribute will be added up to the given set of attributes, so that the new attribute whichever is added to the given set of attributes will help in adding the mining process. Suppose if you have a data set and that does not help in mining process, and if something needs to be added up, new attributes can be added in the data set. And adding such new attributes, constructing new attribute and then adding it to the given set of attribute is nothing but attribute construction. So when you come to the normalization methods, there are 3 important methods that you have in normalization: Min-Max Normalization, Z-score normalization and normalization by decimal scale. So these are the 3 methods. So we'll see one by one. What is Min-Max Normalization? So this Min-Max Normalization preserves the relationship between among the original data values. So this is the formula for the min-max normalization. So V dash, which is a min-max normalization, is equal to V minus the data which you actually wanted to transform. Okay, the data which you wanted to transform. Okay, so V minus minimum of A divided by maximum of A minus minimum of A into new maximum of A minus new minimum of A plus new minimum of A. So this is the formula for min-max normalization. Now let us see a problem. It's just a applicable problem. You are going to take the values and then you are going to apply it here. This is sort of 2 marks. Suppose that the minimum and maximum value for the attribute income are 12,000 and 98,000. So the minimum and the maximum values are 12,000 and 98,000. We would like to map income to the range 0 to 1.0. Now they would like to map the income to the range to 0 to 1. So they are newly mapping our income to a range 0 to 1. So this will become a new minimum and this will become our new maximum. Got it? So now by min-max normalization, a value of 73,600 for income is transferred. So the value that is being transferred, or it's already transferred, is 73,600, which will be our V here. So let us substitute this value as such. So the value that is transferred is V, which is 73,600 minus the minimum value is our 12,000 divided by the maximum value is our 98,000 minus 12,000 into our new max is our 1, new minimum is our 0 plus our new minimum is our 0 is equal to 0.716. So this is what is our min-max normalization. So now let us see about the next normalization problem, Z-score normalization. So here this is also called as a zero mean normalization. The value for an attribute A are normalized based on the mean and standard deviation of A. So the value that is getting transformed is your V, and this A bar is your mean value, and this is your standard deviation. So now let us see the problem. Suppose that the mean and standard deviation of the values for the attribute income are 54,000 and 16,000. So you are having two attributes, that is mean is 54 and the standard deviation is 16,000. Wherever we have got the mean and standard deviation. With Z-score normalization, a value of 73,600 for an income is transformed. So now we have got the V also, where the value is getting transformed. So 73,600 minus the mean value divided by the standard deviation, you will get the value for Z-score normalization. Again, it is a direct applicable problem. The next normalization is normalization by decimal scaling problem. So normalizes by moving the decimal point of values of attribute G. The number of decimal points moved depends on the maximum absolute values of A, and this is the value of the formula of the normalization of decimal scaling. V dash is equal to V divided by 10 to the power J, where J is the smallest integer. So I don't want to get confused with this. So let us see the problem so that you will automatically understand this. Suppose that the recorded values of A range. This is the attribute A. So the value range is minus 986 to 917. The maximum absolute value of A is 986. So the maximum absolute value is 986. So to normalize, the maximum value is 986. So what happens is that to normalize this decimal scaling, what is the closest value for this? So the closest value for this is 1000. So this J will become 3. This J will become, because 10 to the power J. Okay, so it will become 3. So that the minus 986 normalizes to minus 86 divided by 1000 divided by 1000, and also 117 divided by 1000. So the value is normalized to minus 0.986 and 0.917. I hope everybody understood this. Thank you.